R2.10 is on value, interest, and mixture problems. These are all story problems that are going to involve systems of equations, and I'm going to use substitution or elimination to solve them. First thing to do in each of them is to define each variable. Then I want to write a system of two equations. We're going to solve the system, describe the result, or interpret, and to say the result, and finally we can check. In 2004, Usher and Alicia Keys had concerts. Kayla and Lavone sat in the same section for each performance. Kayla bought 4 tickets to see Usher and 4 tickets to see Alicia Keys, and she spent $360. And Lavone spent $220.50 on 2 Usher tickets and 3 Alicia Keys tickets. Find the cost of each ticket. So the unknowns are the amount spent on each type. So we'll choose 2 letters, X and Y, or A and B, or whatever you'd like. How about U and A in this case? So we'll let U equal number, you can choose X and Y if it makes you more comfortable, but number of Usher tickets is going to be U. And we'll let A be the number of Alicia Keys tickets. Number of Alicia Keys tickets. Okay. So that's the first step, right? Step 1 is define the variables. Then step 2 is to write a system of 2 equations. Well, I have an equation for Kayla and I have an equation for Lavon. So the first equation is that Kayla bought 4 Usher tickets. That's 4U plus 4A, 4 Alicia Keys tickets. And she spent a total of $360. That's Kayla's equation. Lavon's equation, he bought 2 Usher tickets, so 2U, plus 3 Alicia Keys tickets, so 3A, equals $220.50. Okay. None of my coefficients is 1, so I'm probably not going to use the substitution method. Instead, we'll use the elimination method. The greatest common multiple of the U's is 8. Of the A's is 12, so we're going to go with U's. So actually it's 4. I thought it was 8 for a minute, but 2 goes into 4 already. So the greatest common multiple is 4. So I can keep that one, a 4. I can multiply this one by a -2, and then I'll have 4s across the U column. Okay. So I'm going to keep this at 4U plus 4A equals 360. And then I'll have -4U, 2 times -2 is -4, minus 6A equals, and I need to do -2 times $220.50 is -441. I just multiply -2 times 220.5. Now add the 2 equations up. This is the elimination method, and the U column eliminates. So I have 4A minus 6A is -2A equals, and I have 360 plus -441, which is -81. And I need to divide by -2. When I divide by -2, I get A is 40.5 or $40.50. Pick any equation to go back into. I will choose the top one just because that was a whole number, doesn't really matter. So I have 4U plus 4 times 40.5 equals 360. 4 times 40.5, 4U plus 162 equals 360. Subtract your 162. 360 minus 162 gives us 4U equals 198. Divide by 4. So we're going to end up here with U equal to 49.5. Instead of writing as an ordered pair, since we have a situation, we're going to write it in a sentence. So Alicia Keys tickets. I apologize, I gotta fix something up here. This isn't the number of tickets. Number of tickets I knew. It was the cost of tickets. Number was they bought 4, right? I already knew that part. My mistake. So the cost of each ticket. So Alicia Keys tickets cost $40.50 each. And Usher tickets cost $49.50 each. All right. So that first example was our value problem. We're going to get one of each of these. The next one's going to be our interest problem. They all have the same basic setup. So in my interest question, a person plans to invest a total of $20,000 in a funds account with a 6% annual interest and a growth account. So funds is 6% and growth is 11%. How much should he invest in each account so that the total interest in 1 year is $1,500? Okay. My question is, how much should they invest in each account? So we'll let X be the amount this time. It really is amount. In funds, and Y be the amount in growth. You could have chosen F and G if you prefer, just changing out my variables a little bit here. Okay, so that's the first step, define variables. Now I'm going to get to the second step, write equations. The first equation is going to come from my total. That's the amount in one, that's the amount in the other. There's a total of $20,000. So just X plus Y equals $20,000. That's the total amount in both accounts. Then comes the interest equation. The amount of interest on the funds account is 6%, so 0.06 times X plus 0.11 from 11% times Y equals the amount of interest, 1,500. Okay, that's step 2, my equations. I want to use substitution because last time I used elimination, so I'm going to pick a likely variable to solve for. They both have a coefficient 1, so it doesn't matter to me. So I'm going to solve for X. Okay. If I solve for X, I'm going to subtract Y from both sides. So X equals negative Y plus 20,000, just minus Y from both sides, right? Okay. Then into my other equation, 0.06X. I'm going to replace that X in a second, right? So 0.06X will be replaced plus 0.11 Y equals 1,500. So 0.06 times negative Y plus 20,000 plus 0.11 Y equals 1,500 or 1,500. Distribute. 0.06 times negative 1 is negative 0.06 Y plus 0.06 times 20,000 is 1,200. And then I need to add my like terms together, my negative 0.06 plus my 0.11, which add up to a positive 0.05 Y, plus the 1,200 equals 1,500, and I need to subtract the 1,200 from both sides. So 0.05 Y equals 300, and then I divide. So 300 divided by 0.05, which gives me 6,000. Okay. Now that I have one value, Y, I can find the X value. Remember that X was equal to negative Y, so negative 6,000 plus 20,000, which would be 14,000. So it seems like there was 14,000 in the X was funds account and 6,000 in the growth account. On the next page, we will get our mixture problem. Type 3, mixture. A chemist wants to mix a 15% acid solution with a 35% acid solution in order to make 30% of acid in the solution. How many quarts of each solution must be mixed to make 4 quarts of the 30% solution? So X and Y sound good here again. How much or how many quarts is my question? So X equals number of quarts of the 2 that we're mixing, so that's 15% solution. And Y is number of quarts of the 35% solution. Those are the 2 that you're mixing. If you just mix them, the number of quarts you need of this one, the number of quarts you need of this one, you're going to get your total of 4 quarts. So the first equation is going to be X plus Y equals 4. Now their acid amount. The 15% solution is only 15% acid, so 0.15 X plus 0.35 Y is going to give you the amount of acid in the mixture. 4 quarts isn't the amount of acid, 30% isn't the amount of acid, but the amount of acid is 30% of 4 quarts. So just like I need a product here, a percent times an amount, and a product over here also to match my units. So 30% of 4 quarts gives me the amount of pure acid in that equation. Okay. Last time we used substitution, so this time let's go ahead and use elimination. I could make my x's both 0.15, so my y's both 0.35, so I choose x 0.15. So I'm going to multiply this first equation by negative 0.15 all the way across, and then we'll be able to use the elimination method. Okay, so first of all, I need to do negative 0.15 times x, that one I don't need to calculate for, negative 0.15x minus 0.15y equals my negative 0.15 times 4, which is negative 0.6. Then I have the 0.15x plus 0.35y equals 0.30 times 4, which is 1.2. Add the 2 equations up. The x's eliminate, and the y's add up to 0.35 minus 0.15, 0.2y, and then 1.2 minus 0.6 is 0.6. Divide by 0.2. Y is 3. Okay. And I already knew that x plus y was 4, so x plus 3 is 4. That means that x is 1. So that means that what we need to mix is 1 quart of x, which is 15%, with, that was abbreviation for width, that'd be slash abbreviated with 3 quarts of 35% solution. And that finishes R2.10.